interesting chapter, and moreover, you know everything about this chapter. You have already studied the laws of motion at your high school level. Then in our bridge course also we have studied about the all three laws of Newton's also. Okay, so it is laws of motion, or you can simply say it is Newton's laws of motion also. Okay, so the first time there are so many people have changed this word, in that the Newton is at the top. He is what changed almost all the physics of the world. Okay, so that is what the great story when Newton was sitting under the apple tree. So apple fell down. He thought why apple did not go in this direction, why it is coming down only. So then he go on thinking on that one. Then finally what happened, he concluded that earth is having some attraction power. That is what he called it as the gravitational force of attraction. Okay, so after that he has given the idea of the laws of the nature which governing the motion. Okay, so how what are the laws governing the every particle moving in this world, how the force acting, or how the direction changes, what make the body to be at one place, or what makes the body to move from one place to another place. For all those things, till that point what has happened, the simply things were going on. Then he formulated some ideas, some equations which can govern all these motion. Okay, so he has given three very important equations of motion, from which you can totally describe the motion of any object. Okay, so that is what all about the how that laws of motion came. And before Newton only, there was one more person who was suggested about the laws of motion. That is what not he has not given about the laws, but he has started in a right way about the describing the motion. That is that person is none other than what Galileo. Okay, so what he has done a few experiment. He suggested ki yes, the motion is not simply it is taking place. There are something which is governing it. Then he formulated the idea of inertia, why the body is at rest, or why body is moving. What is required to change this motion, or what is required to change the state of rest. So that property he called it as inertia also. So before Newton, he has suggested, he has given little idea about the motions. Okay, then these two are the modern. Before then only there was one more person who was suggested about who was first attempted to describe the motion. That person is none other than Aristotle. Okay, the great philosopher Aristotle. So he suggested that there is a continuous force is required to keep body in continuous motion. Somehow he may be at the end he may be failed. Today he may be wrong, but there is some initiation he has taken and given the idea of the motion. So he suggested continuous force is required. So for some time it was taken as correctly, but today it is going to be it's going to be wrong because of the experiments done by the Galileo and the equations given by the Newton. Okay, so but whatever the work he has done first in his first attempt, that is a thing which we can take help to go for the next level of the describing emotion. Okay, so this is what he has given a statement. We are what we repeatedly do. Excellence then is not an act but a habit. Okay, so what we do repeatedly, he is a philosopher, that is what he has given. What we do repeatedly, that is what we will become. Okay, so excellence is not something we have to do in this way. It should be it should be a habitual. Okay, so as you what thing you do repeatedly, if you do good things repeatedly, you will become a good person, or you will get something good. If you do bad things repeatedly, obviously end will be very bad. So keep this sentence also in mind. I'm taking this sentence because we are talking about the philosopher. Again, we will go back to what laws of motion. We will start with the laws of motion. Hope you will enjoy this chapter. So let me start with the laws of motion. We start with Aristotle's fallacy. Okay. So Aristotle's fallacy. Aristotle's fallacy. So what do we mean by Aristotle fallacy, or what he suggested through the Aristotle fallacy? What he suggested is a continuous external force is required. Continuous external force is required to keep a body in motion. Okay. Actually, it seems to be very correct, because a continuous external force is required to keep a body in motion. Okay. Obviously, if there is an object, if you just apply some force, what will happen? It will move for some distance. So after moving for some distance, what will happen? It will comes to rest. So again, if you are expecting that body to be in continuous motion, what he suggested, a continuous external force is required. Okay, again you have to apply the external force. So what will happen? Again, it will move for some distance. Then it will try to come to a rest. So what will happen? Again, he will apply some force. So again, it will move. So this is what he suggested. Continuously, you have to keep on applying the force on an object if you want to keep that object in motion, or in the what you can say in constant motion. Okay. So for this here, he has given the idea of, or the example of arrow also. When arrow started moving from the bow, so what will happen? So it will start moving. Okay. So it continues to be in motion for some distance. It continues to be in the motion for some distance. So he suggested, what is making this arrow to move? What is the external force making? Because a person who has given the initial force, he cannot come here again push it. Again he cannot come here again push it. Then what was that agent which is making this arrow to move continuously? Okay. So for that he has suggested the air behind this. Here also, air behind this is pushing it continuously. Air behind this pushing it continuously. Again, the air is everywhere there in the atmosphere. So it is pushing it continuously. So that is giving what the external force required. Okay. So external force required is given by what? Is given by air. Okay. So that is what, with this example and the physical example, he concluded that a continuous external force is required to keep a body in motion. Obviously, it seems to be right, but later when the people started studying on that one, they suggested this concept is wrong. So then how this is going to be wrong? Because he is absolutely right. But what people thought, how this air can apply the force? How, because of this air, how this arrow can move in the same direction? If air is there everywhere, it may change its direction also. Getting the point? So the people have the problem with the statement that is a continuous external force is required to keep a body in motion or in continuous motion. Okay. So for that, if they are saying this statement is wrong, then you have to prove that. If they are saying this statement is wrong, they have to prove that. So then they have taken the example of the toy car. So if there is a toy car, okay. So if a child is playing with the toy car, so what he will do, he will connect a string over here. So he will connect the string over there. Then the boy will what he can just pull it. Okay, he can just pull it. Then yeah. So what is happening? There is a car, or you can say toy car. So there is a toy car, and this is what we want. Okay. So this boy is applying some force in this direction. Okay. So he has applied some force. So what will happen? Car will move for some distance. Okay. So when he applies some force, car will move for some distance. Okay. So now car will come here. Okay. So it has moved some distance from here to here. Okay. So because of what? Because of the force applied by the boy. Okay. Now what will happen when he just pull it? Then what will happen? The car will move for some distance. Again, what will happen? Car will come to the rest. So if you want to move it again he has to pull it. So what will happen? Again it will move for some distance. So what will happen now? The car will come over here. So what will happen? Again it has moved some distance because of the force applied by the ball. Okay. Then the whatever he has given the example, the air behind the object pushing the arrow, or behind the arrow, pushing the arrow is going to be wrong, because here also air is there, here also air is there, here also air is there. If that is so, once the boy pull it, once he applied the force, so it will start moving. Once it start moving, if it is true that the air behind the toy car is pushing it, or the air behind this arrow is pushing that arrow, or applying or giving the required external force, then that should be true in this case. Once the child pull it, the air behind this will continues to be applying the force, and the car should move without applying or without pulling by the child, or without applying any force. But that is not happening. As soon as the child pull it, it will come for some distance, again it will stop. It will come for some distance, again it will stop. Then what making it to stop? Why this air is not applying the force? Why the body is not moving? All those are the confusions. Okay. So then, according to this statement, a continuous external force is required to keep a body in motion. Obviously, if this air made this body to move, so that can be acceptable. Then that means air is not applying the force. Then whether the statement is wrong or the example is wrong, or the confusion. Okay. So when he pull the force, pull the car with the help of applied force, what will happen? It will move. Once it moves, obviously object will be continuous in the state of motion only, not because of this air. If we take the ideal situation when there is no the opposing force, it will be in continuous state of motion. Then why this boy is again applying the force? Why this boy is again applying force is a question. Okay. What is the law, correct law today? When once the body start moving, it will be continuous in this state of motion. So no force is needed. Then why this boy has to apply the force? This is what question of Ian Gallery. Getting the point. So he is applying force in order to, why it is coming to rest? Because of the friction force. Because of the friction force. There is a friction which is opposing the motion of the object. There is a frictional force which is opposing the motion of the object. Okay. So this friction force is applying opposite force. So that is why that toy car is coming to rest. So if this frictional force is not there, once he pull it, it will be in continuous state of motion. Because of this friction, this boy has to apply the force. Why he has to apply the force? Just to cancel this friction. The force applied by the body will just cancel the friction force. This he has to pull it till the F is equals to the frictional force. Okay, so the force applied by boy is just to cancel the frictional force. He is not applying any force to move that object. Getting the point? He has to apply the force just to cancel the friction. That means what? Body is in motion only. Because of friction, it is coming to rest. Okay, so that to cancel this friction, boy is applying the force. So the force applied by the boy is to just cancel the friction, not to move the body, not to keep body in motion, not to keep body in motion. Okay, so this is what the example given by the people to in order to disprove the what Galileo. Okay, so as suggested by Galileo, air will not apply the force, and as given the statement given by Galileo, continuous force is required by an object to keep it in motion. That is also what going to be wrong, because once the object is just apply the force, once the force is applied on the object, so it will be in the continuous state of motion. No force is required oftenly to apply on that one. But this is possible only in case of what? Only in case of ideal situation. Ideal situation means there is no friction. There is no friction. Okay. So in the ideal situation, or on the frictionless surface, no force is required. Continuous force is not required. Once you apply the force, body keep on moving. Okay. So in the inverse, the body in motion, to be there in the state of motion, so for that no external force is required. Okay, so but if you look at the Galileo, he was also somehow right, because there is no the ideal situation in this world. Everywhere you can go, there will be a friction may be due to air, there will be the friction on the surface. Okay, so all these things, it is quite difficult to get the ideal situation like getting the frictionless surface. So that is what Galileo thought. Maybe according to situation he maybe concluded that one, but what is the truth is the continuous force is required to keep the body in motion. Okay, so this is what this example disprove the Aristotle's fallacy. Okay, so what he suggested was going to be wrong. A continuous external force is required to keep a body in motion is proved that it is going to be wrong. Then what is the right? What is the right? And that to find that right thing, one more experiment has done. That experiment was done by the Galileo. Okay. So next, the Galileo has given one statement. Galileo. So what he suggested? No external force is required. Very bold statement has given. No external force is required to keep a body in constant motion. Okay, so what he suggested is to keep the body in a constant motion, no external force is required. Okay, so you can say with constant motion or with constant velocity. Okay, with constant velocity. With constant velocity means there is no acceleration, there is no retardation. Okay, so this statement was given by what? This was given by the Galileo. Okay, for that he has done few simple experiments also. What he has done? He has taken an inclined plane. Here he has taken an inclined plane. He made a body to move on this plane. So it started moving. So what has happened? So here velocity, say it is v. So as it start moving, velocity was increasing. Obviously it will increase. So what is happening here? So body is accelerating. Obviously, as the velocity increases, we can say that it is accelerating. So instead of this one, he has taken another inclined plane in the opposite direction, or not in opposite direction. So he made body to move in opposite direction. So let me take the same inclined plane. Okay. So what he has done is he made body to move in this direction. So with the velocity v, he has applied some force. So as it start moving, its velocity go on decreasing. Okay. So here what is happening? Here body is retarding, means velocity is decreasing. Okay. So when he thought of another ideal situation, that is when he make a body to move on the plane. So once he applied the force, when he started moving, obviously it was moving with the same velocity for some distance. Okay. This was the intermediate situation of these two. Here what velocity was increasing, here velocity was decreasing, but here the situation was intermediate. It has moved with some constant velocity. So with the help of these three, these three simple experiment, he has concluded something. What he has concluded, to keep a body in motion, in constant motion, no external force is required. No external force is required to keep a body in motion. Okay. So from this experiment, what he concluded, Galileo concluded that a body moving on, a body or object moving on a horizontal frictionless surface, a horizontal frictionless surface must neither accelerates nor retard, but move with constant acceleration, with constant velocity. Okay, with constant velocity. Okay, so if the moving surface is horizontal and frictionless, what is suggested? It neither accelerates nor retards. It will move with a constant velocity. That is what he concluded, and somehow he was very right. Okay, so he has done one more experiment. What he has done? He has taken the plane for the two-side inclined plane. Okay, so he has taken a plane like this. So he make a spherical ball to move over here. Okay, so when he free to move, what has happened? It used to come to a height which is almost equal to the height of the initial. Okay, or initial height. So this is what going to be equal. So final and initial heights are going to be equal. Okay, so this is what the distance x. Okay, so this x, if you apply some amount of force, what has happened? This ball has moved this much of distance. That is what the force you have given. So suppose instead of this one, if the plane is suggested somewhat like this. Okay, so what he has done, now it is little inclined, sorry, the inclination was decreased. Okay, if you make it like this. Okay, so now the same amount of force, or say it again, the spherical sphere is made to free to move over here. So what has happened? Suppose this is the height h. If this is the distance x from here to here, if this is the distance say x, so it should come till only here. It should come only till here, up to this mark. Okay, but it is not happening like that. It trying to come at this point only, means it tried to, or it was reaching the same height. It was reaching the same height. Okay, but distance traveled was more. Okay, for applied or for the applied force F, distance traveled is x. For the same applied force F, so distance traveled should be x only. It should be x only, but some extra distance was covered here. Some extra distance was covered. Then from where that extra distance was coming? from here that extra distance was coming. That means there is some external force applied. But is anybody applying the external force? Nobody is applying the force. That means once the body starts moving, it continues to be in the state of motion. No external agency is required. So that is why till to come to that height, it just keep on moving, because its property is only to be in the motion until it will get some opposition. Okay, so this is what given some support to accept his statement. Okay, so later what he has done, he has taken one side inclined plane, then he make it to horizontal. So when the sphere is made to free to move, so what has happened? It was just moving. It was just keep on moving. It was just keep on moving till infinity. Okay, so it must have traveled only this much distance, but it is going to infinity means what? That means if according to Yellow some external continuous force is required, then who is applying the force over here? Nobody is applying the force. That means to be in the state of motion is itself a property of what? Is itself the property of the object. Okay, so if external force is not applied, the body which is moving continues to be in the state of motion. Okay, so if an external force and if an external force is zero, then object is continue to be in the state of rest, or to be in the state of uniform motion. Okay, or to be in the state of uniform motion. Okay, or you can say simply with a constant motion. If an external force is zero, then object is continue to be in the state of rest or uniform motion. Okay, so here body was moving. When you take an inclined plane, so some opposing force is acting, so that is why it is coming to rest. Okay, here you have little what you have taken the you reduce the inclination. So what has happened? It is moving, but still it is moving only. Till then you give the required external force, so then it is coming to stop. If you do not give this external force, it will be continuous to be in the state of motion. That is what happening here. Okay, with the help of this experiment, he has given a statement, that is what, if an external force is zero, then object is continuous to be in the state of motion, or in the state of rest or uniform motion. Okay, so this property is called, very important, this property is called what is the the famous word, that is what? Inertia. This property is called as what? This property is called as inertia. This is the very important word in the study of what? In the study of laws of motion. Okay, so what is the meaning of this inertia? What is the meaning of this inertia? Okay, so meaning of this inertia is what? Resistance, we can say something, resistance to change. So meaning of this inertia is what? It is resistance to change. Okay, so resistance to change. Okay, so first time he has given the idea of what? He has given the idea of inertia, and this is what he called as the law of inertia. This is what he called as the law of inertia. Okay, so very important. This is what this word is taken by the Newton, and he explained all these laws of motion. Okay, So one of the very important one, inertia. Remember this one. We will study about the more about the inertia. What are the types of inertia and what exactly inertia and how it can help to study the laws of motion in our next.